So today's topic for the webinar is e-bikes on trains, and the content of today's webinar is following. So I'm going to have a brief words about IFAB, who we are, what we do, and then we will then go straight to the topic, which actually compiles 2 fire test programs with e-bikes, very recent ones, and I will present what we did, and then I will focus for the main results from these 2 programs and the main conclusions. And if we have time today, so we will then have also questions and answers. We have received quite a few questions already in advance, and we tried to tackle those, but nevertheless, you will get a possibility then to send the questions afterwards, and we will try to reply to those. You will get the contact details later in the end of the webinar. Right. So if we start with IFAB, so IFAB stands for the Institute of Applied Fire Safety Research. We are founded in 2008, based in Berlin, Germany. In the early days and traditionally, we were focusing very much to fire and smoke testing. But nowadays, the focus actually is probably more on traditional fire safety consulting and design. And under this umbrella, basically, we do, or we cover quite some different applications and different design methods and tools. But we are still also ISO EN 17025 accredited fire test laboratory and related to rail or rolling stock. So we, for example, we do the tests of fire and smoke tests under ARJA and UNI standards. The services in rail sector actually cover rail is the topic today. Is covering, let's say, fire safety concept for the rolling stock manufacturers. We also help assessing and compiling the material test reports, especially important with EN 45545. We also give trainings regarding the standardization, that if there are new companies entering the rail market, how they should consider fire safety. Approval fire tests, as I mentioned, it's still an important part of our work, but research and development is something we've been very, very active. And obviously today's webinar is about this topic. So we try to do, especially with the special hazards, and here you see on the right hand side, we, for example, last year we burned a complete code, a new code to define the heat release rate curve of that specific vehicle. But on the CFD side, we are utilizing our experimental data, and we are working especially with metros quite a bit. To show you the example brands we are working with, so probably you are coming from some of these, or you definitely recognize. But then moving to today's topic, which is e-bikes in the context of rolling stock. And we started 2021, diving in a bit more deeper in this topic. And our motivation was that suddenly we start to see scooters or e-bikes in different contexts, and they might be related to the shops, garage, parking places, and obviously, since we are active in rail sector, that was of interest to us, and we recognize that there's actually very, very little information available in terms of heat release rate. How is the fire propagation from one bike to the other? What kind of gases they produce, and what is their impact then to life safety? And this was actually the initial start for the testing. The very first test series which we did was actually still more experimenting, trying different ignition methods. We only had, let's say, a number of different used bikes, and it was more, let's say, during the first trials, and we tried to evaluate the temperatures, potential fire spread to surrounding. Obviously, we had ARCHA guideline in our mind all the time. So that was, let's say, the scenario which we created, and we also tested actually onboard fire suppression system already now, giving a try for one mitigation method in this early test, and we got it from Germany, from FOGTEC. High pressure water mist system was what we were testing, and actually the test setup, like I said, consisted these ARCHA sheets. I don't know if you're aware of the ARCHA guideline, but that's basically set for how to test for smoke detection or fixed firefighting system or onboard firefighting system. So we actually, when modifying the seat arrangement, we use the same IMO cushions, so standardized fire load. We focus a lot to, let's say, temperatures, but we did not have possibility to measure the heat release rate, and that was basically the setup. And what we actually found out was then, can I get the, I mean, here you see the bit better the test arrangement, but you see that if we are looking that when, let's say, the first cells ignited, already the battery casing was burning, and if we are looking to the image 90 seconds later, so we actually recognize that okay, this is probably a little bit different that we have seen in the previous fire tests, and when looking the very same or similar tests also with the thermal camera, we see very well the fast fire development, and we also see that the fire actually jumps relatively quickly then to the seat when the battery goes to thermal runway. Obviously, this video is now actually made a bit faster, but it well shows how the fire develops then to the surrounding. We did exactly the same. Here's another video. We did exactly the same with water mist system. I mean, obviously, this was just very first trials, and it was like a generic system, but we already noticed that this was, let's say, it was possible to contain the fire. But these were our first experiences going to this theme. And basically what we learned from these tests is that the fire size is surprisingly high. The growth rate is actually probably a bit faster than we were expecting, and but nevertheless we could have the fire contained with the onboard fire suppression. But we recognize that I think we need to do much more work with the bike itself, and we should try to get a grip of the heat release rate. I mean, what these fires actually in real, what do they produce, and we obviously need also this data that when we are using the CFD. So I mean, we need to have some sort of experimental data to utilize such tools, and we also recognize that knowing the gas concentrations and, let's say, toxic gases, that would be of importance. Then we moved to a second fire test series this year, and this was actually way more, I would say, larger by all means. So actually, we had a very extensive setup which I'm going to explain a bit later. But we also used quite a bit of time to study different kinds of e-bikes, and because we wanted to create a kind of reasonable worst case scenario, and obviously the bikes, they can vary a lot in terms of the battery capacity, in terms of the bike size, the other combustible material, and nevertheless we started different bikes, and then we picked one which we considered being, let's say, probably not the absolute worst, but close to that. I mean, having a relatively high battery capacity, so 660 watt hours, 48 volt system, and this was a kind of generic bike for our tests. We had also many other types, especially used bikes, which we were also testing. And this generic bike, we actually had multiple, or we had few pieces. They were brand new, and we tested them with both without additional fire load, so just the bike itself, no other material. But then we created another scenario where we combined that with the kind of additional bag which the bikes normally or quite often are having, and we filled the bag with the Archer travel bag. So again, a kind of standardized fire load which we put inside of this bag, which you see actually green here in the image. The test mock-up, as you know, the measuring the heat release rate is not very easy, and we had an opportunity. We often do it with the hood kind of calorimeter, but this time we had an opportunity, since we carried out some other fire tests. So we had a kind of tunnel shape mock-up which we could use. We did some modifications in the reducing the cross section to get the velocities higher and better to the center. We had a quite massive measurement system, probably actually even more that we needed for these tests, and we had also many, let's say, cameras recording in different angles what happens, and we also used the thermal camera to catch what's happening. We used the pool fires to calibrate the heat release rate measurement, which is also an important part of the test protocol. The mock-up looked like this. So, like I said, it was tunnel shaped. We were able to do a kind of small air movement through the tunnel, providing, let's say, fresh air, and then collecting all the air in the end of the this tunnel shaped geometry, and then analyzing the gases, and also the oxygen, which is the main parameter when defining the heat release rate. Here are the different measurement positions shown, and the bike was in the middle, like you see here in the image. The total length of this mock-up was around about 12 meters plus then the extension. This is how the mock-up with the generic bike looked like. And this is the bike before the tests, and this is the bike after the test. As you see, the battery is located in the frame, in the middle of the frame, and obviously that's where the main interest for us was, and we actually ignited the battery using the temperature. This is now the video showing this specific bike typically burning. So here you see from different angles. This is when the battery goes off, and as you see, the fire development is very, very rapid. So it's a very intensive fire in the beginning, and then the fire spreads to the other combustible material in the bike. And obviously, if there would be something in the surrounding of this bike, you see that the frame actually now gave up, so the aluminium already melted. But this was a very typical fire behavior. And here is the measured heat release rate. So as you see, the peak in this specific, this was actually the highest we measured. So the peak value was really high. Obviously, it was for very short duration, but the peak was high. The conclusions with this generic bike in general is that the battery will, in the end, will ignite also all, let's say, combustible parts of the bike. And we had only the front tire, which did not burn completely, but that's partly due the ventilation. The ventilation is not very strong. It's just keeping air streaming one way, but we didn't want to boost the fire or interrupt the fire anyhow by the ventilation. The peak value was approx 1 megawatt, and for us actually with some of the tests, the smoke generation was so fast when the battery went to thermal runway that we actually had to increase a bit the ventilation speed during the testing, that we would get the fumes going the right way and to the center. So we did burn these pikes also with the travel bag, and our interest was to see that, okay, how much such a bag attached to the bike, how much would that influence the fire, and how much that would be in when compared to the battery itself. Here you see how the bike actually looked afterwards, and we have also the video, but this time thermal camera showing when the fire is really picking up. So when the battery goes to thermal runway. So this again has been made faster, so it's probably approx double speed. But we see that first the battery goes off, and then same way it ignites all the other combustible material in the bike, including the bag. So the bag also started to burn after the battery was in thermal runway. We see that the saddle is melting, and then the whole bike collapsed because the frame gave up partially. And the heat release rate curve was actually was quite a bit different. So in this test, the peak value did not go that high, but still, let's say, high compared to what we are getting with the bag itself. So the difference was that if we are looking with this generic bike, I will demonstrate that also later. But just with the battery, the fire will actually reduce in size much faster. But now obviously the bag keeps burning over a longer time, and that makes the heat release rate different. When looking to temperatures, so I mean, these are probably not, let's say, very representative for the real wagon or real car, because the ceiling height was very low. But this just demonstrates that temperatures directly above the fire, they were relatively high. You see the distances are with the 50 centimeter upstream is another thermocouple, and then downstream 2 thermocouples, and this just shows that then the very similar temperature behavior we saw with the thermocouples measured than the heat release rate was. So to conclude our generic bike with the bag, so again, most combustible components really burn away. Battery started at the big peak in the beginning, and then gradually, let's say, all the other combustible material will burn. But definitely the bag was ignited, and that kept burning over a longer time. So whether the battery is able to let's say, ignite goods which are attached to the bike, so it's very, very likely. We did do also some other bike arrangements and with the different bikes, and this just shows an example where we had a different kind of bikes where the battery was in both bikes in the back side of the bike, or mounted to a different location. And we wanted to see that how will be the fire propagation then from one bike to the other. And in most of the cases it happened, but in this very specific test it did not. So the second bike and the battery of the second bike was damaged, but it didn't really go off, or it didn't start. The thermal runway did not start. So that was a kind of, let's say, experiences which we also did during the test. So if I would try to draw now a kind of main conclusions and showing the main results. So as said in the beginning, we had a lot of focus on the heat release rate, and so we successfully we measured it. The peaks were actually higher than we expected, but obviously there's always discussion that how is then the accuracy of the heat release rate measurement, and we try to evaluate that also with the energy balance. So we compared that how much energy was put into the fumes in the air to heat it up, and it actually in most of the tests it's correlated relatively well to our heat release rate measurement. So that was a positive surprise. When looking to the data which we generated, so all the bikes, they had very, very similar behavior. Once the thermal runaway started, once the battery was ignited. So we obviously were doing the ignition artificially, but normally this would happen automatically by some reason. And this is the moment when the fire will start. And we had the very similar pattern, except when looking to the bike, which had the back and the other goods attached. And based on that, we actually generated a design fire curve, which we think which is a reasonable worst case scenario. According to our measurements, it really covered, let's say, 90% of the cases, and this is something that we would recommend to use. The other things which we were doing was that we used the FDIR to analyze all variety of the gases, and obviously HF is normally the most discussed gas when we are talking about the lithium-ion batteries, and we measured 12 ppm, but we are still analyzing because we have to understand that what does this mean in the context of having continuous ventilation there. I mean, it was not a lot, but it was not the closed volume, and the work is still ongoing, trying to analyze that what these values have to do with the life safety. As main conclusions through these 2 fire test campaign, we would say the following. We actually did a representing heat release rate or design curve, which we will be actually using also in other contexts than rolling stock, but this helps us to evaluate and you know, many different other things like the heat exposure or evacuation. But this is still not the end, so we are still going to work also with this topic. But we can I go backwards, Alexander? There are also different mitigation methods, and we already recognize that onboard fire suppression is definitely good. Ventilation, HVAC can be also utilized. Emergency procedures, they are extremely important, and then also the risk management. How do we prevent fires occurring on trains? And you just see a very good practice here with a power plug, with a socket, that no e-bikes allowed. And then in the future, we are going to work more analyzing the results. So especially with the gas concentrations, we are going to continue the fire test, especially with the fire propagation to surrounding the other e-bikes, and definitely also with the different mitigation systems like fire suppression. And interesting is going to be that how this data can be used in other contexts. So this was actually today's webinar. We had some questions, but we are now going on overtime. But we have some questions. I'm trying to answer at least 2 of them. But if you have any other questions, just email us or email to me. We are trying to reply. We are going to send you also afterwards handouts, a short summary of this webinar. I hope this was of use to you, and there's a small poll coming up, hopefully, that you can also evaluate this webinar. But since we are running late now, I'm using 2 minutes overtime. And if you can't stay, just then thank you for participating. We are happy that you joined, and if you still can stay there, I will try to quickly answer the questions we received. And the very first question is that are we going to continue the work with the e-bikes in relation to trains? Yes, we are going to do the work. I think our presentation already stated that there are various different topics, and we've been discussing also potentially some research projects, and it's important to see that how this is going to influence in the such confined space the life safety. We already received also a question regarding the heat release rate accuracy, and we were trying to use different methods to be as accurate as possible, but it's not possible to do 100% accuracy. We all know this. But typically, when using the oxygen depletion method, I think we are good, let's say, in plus minus 20%, plus minus 15%. We did the calibration in advance, and we have been testing lithium-ion batteries also a lot, so we know some of the corrections which we need to do. But as I said, we managed to relatively well correlate with the thermal effects to see that when we were simply analyzing that how much the fumes were heated, so that matched quite well. But we are already 2 minutes over time. I really appreciate that you have joined this webinar. Hopefully we will see you in some other context, but I wish you a great day, and thanks for your time that you participated. Goodbye.